Good afternoon. This is Dr. Heidelberg. The presentation today will relate to robot index table interaction with I/O control. This is Simulation Lab Tutorial 3 using RoboDK software for simulation and offline programming. The lab objectives include viewing a real robot index table interaction. We will then configure the simulation, which is equivalent to what we see on a real video. We'll write a program using I/O control, simulate the process, and write a report. The lab procedure is similar to the previous two lab procedures. We'll create and save the processing. We'll upload the tools and parts. We'll set the process reference frames and the tool center points. We'll teach the robot position, teach peripheral equipment position, write auxiliary subroutines with I/O signals, write the main program, simulate the process, record the process, view the cycle time, and write a report. The real robot index table interaction is taken from the 2018 assembly show. We can watch over here in this video two SCAR robot, FANUC robots. The left side robot is picking up parts from the table and placing it on an index table. The right hand side robot is taking the parts and putting it on a linear conveyor system. The actual simulation can be viewed over here. We see the process. Right now we can make it faster. The left robot is picking apart, putting it in the index table. The right robot picking it from the index table, putting it on a linear stage, and the cycle repeats itself. The scene will include the following objects taken from RoboDK menu. We'll have a SCARA robot, Toshiba THL800 on the left-hand side and also on the right-hand side. The left-hand side will be placed on a table. Also, we'll have a part on the table to start with. Then we'll have ABB IRBP A250D 1000 index table. In between the two robots, the right robot will be placed on a 1 meter by 1 meter plane, and in front of them we'll have the KUKA KL253 linear stage. The target positions for the robots and the peripheral equipment include, for the left-hand side, we'll have home, we'll have pick position, then we'll have index approach position and place position on the index table. The index table will have home and then unload position. The right robot will have home, pick position. You also have an approach position to place it on the linear stage and also a place position. The linear stage will have a load position and unload position, and the left robot will also have approach position towards the linear stage and a pick position from the linear stage. The subroutines will include the left robot moves, starting with the home position, going down to pick the part, then attaching the part, going back to the home position, moving to the approach position of the index table, placing the part, detaching the part, moving back to the approach position, and letting the index table know with IO1 that it is left the scene and the index table is ready to roll. The index move will start with the attaching the part, then moving to the unload position, detaching the part, calling the robot on the right to move, then moving back to the index table and setting up the I/O signal, letting the pick robot that it is ready with its part. The right-hand robot will move to the home position will wait to get the signal from the index table that it is ready to pick it up, and then it will go to the pick position, attach the part, then retract to its home position, set the IO signal 5 that it clears, and the index table can go back to original position, then move to the approach position on a linear stage, detach the part, move back up, and then move back to the home position. The linear stage will move to the load, set up the IO signal 7 to indicate that it is ready to accept part. Then it will attach the part, move to the unload position, detach the part, call the left robot to pick it up, set the IO signal 8 to 1, and then move back when it's finished to the loading position. Then the left robot will go back to the pick position of the part from the table. It will go to the approach, pick it up, then attach the part, and go back to the approach and back home. We can reset the parts with this subroutine, and the main program is simply calling the left robot move, and then the index table move, and then the linear move, and calling the reset. The process simulation can be seen over here when we click on the HTML. This is the final demonstration. We see that the cycle time is 38.5, although it is shown over here on RoboDK as the standard scaling factor of 5. So the real process is 5 times slower, and the number of seconds is indicated over here. The final part of the lab is to write the report, including the objectives, the screenshot of target position, the software, and the HTML. What I like to show here is when we set up the process scene, it is useful to come to view and click on a workspace. This shows us where the robots can reach. And what we see here is that the pick position of the robot is actually the place position here and the pick position here when we write the software is right at the edge of the work envelope. And this means that it is recommended to move the linear stage towards the robots in order to move the place and pick positions from its periphery of the environment. Also, we see that the robots are limited to certain angular displacement of their links. Therefore, in certain areas, the work envelope is truncated and limited, and that's why we would like to place the robot in the orientation such as this one, which will maximize and optimize the workspace. This completes our presentation, and we will continue with more similar tutorials of using RoboDK. Thank you.